alkynes are prepared via elimination reactions. When using a strong base, we can do two eliminations in a row that will give us the two pi bonds that we need for the double bond. So for example, if we have a geminal dichloride, geminal means that both chlorines are hanging from the same carbon, and we use a base such as NaNH2. Remember that we have to use two equivalents because there will be two eliminations that are done back to back. And so here we have two H hydrogens. The first one will be taken away by the base, and one of the chlorines will leave. That will give us the double bond, and then another equivalent of the base will come, get the other H, also collapse, and then the other Cl can leave, and that's how we get a double bond. The same happens when we have a vicinal dibromide. That means that the bromines are not on the same carbon, but they are on carbons that are next to each other. In this case, we have one H there and one H here. So we will be using, again, two equivalents of bases, and that's of base, and that's why you keep saying these two in front of the base reagent. And so as I was saying, first one base or one equivalent of the base will come, and then that Br will leave, and another equivalent of the base can come and get the other H, and that will eliminate it. In any case, either if you have your halogens being geminal or vicinal, the result is the same, and we end up having an alkyne due to two successive E2 eliminations. So here you have the mechanism again. Here we have a strong base. Remember, this usually comes as NaNH2. And so the negative charge here is going to come get the hydrogen, and that's going to collapse here, giving us one double bond. The Br is going to leave. So we go through this intermediate, the alkene. We could stop here very well, and this will be a simple E2 reaction. But when another equivalent of NH2 is used, then the other H is taken away, the double bond is formed, and the Br leaves, and that's how we end up with the alkyne. We can, here there is another example. So right here, I can start from the alkyne. So if I start with this alkene, the alkene, what I'm gonna have to do is first add the bromines, right? Because there's no way for me to eliminate these two H's if there is not a good leaving group. In other words, there is no way for me to go from A to B directly. What I have to do is take the double bond, add the two Brs, and then do the two eliminations that will yield that alkyne. So I'm going to say this again. We can get alkynes from alkenes, right? But so A to B, but we cannot do that in just one step, right? Because we cannot simply use base here. There has to be a leaving group in an elimination. So the way that we go around it is, first we take the double bond, we add the two Brs, and they are in a vicinal situation. And once we have the two Brs that are my leaving groups, then I can do that double elimination. And by that double elimination, I can get the two pi bonds that give me the alkyne that I'm looking for.